Good morning, students. Today we will discuss about the vapor pressure lowering. That is nothing but the colligative property. The colligative property is nothing but it is the physical properties of the solution that depends in the number of solute particles in solution, but not on the nature of the solute particles. Such a property is called as the colligative property. These are the vapor pressure lowering, boiling point elevation, freezing point depression, and the osmotic pressure. Now today we will see about the vapor pressure lowering. While dealing with the colligative properties of the non-electrolyte solution, the relatively dilute solutions with concentration of 0.2 molar or less are considered. When liquid in a closed container is in equilibrium with the vapor, the pressure exerted by the vapor on the liquid is its vapor pressure. When a non-volatile solid is dissolved into the solvent, pure solvent, the vapor pressure of the solution is lower than the pure solvent. In other words, we can say that the vapor pressure of the solvent is lowered by dissolving the non-volatile solute into it. When the solute is non-volatile, it does not contribute to the vapor pressure above the solution. Therefore, the vapor pressure of the solution is equal to the vapor pressure of the solvent above the solution. Suppose that P1 naught is the vapor pressure of the pure solvent. P1 naught is the vapor pressure of pure solvent, and P1 is the vapor pressure of the solvent above the solution. Vapor pressure of solvent above the solution. Then P1 is smaller than the P1 naught. The vapor pressure lowering, that is delta P, is equal to P1 naught minus P1. Means pure solvent's vapor pressure is greater, larger, but when the non-volatile solute is added into the pure solvent, at that time the vapor pressure will be decreased. Hence, the lowering of vapor pressure. Meaning, suppose that this is the container, and this is the solution. The vapor pressure of the pure solvent at this stage, and when the non-volatile solute is added, non-volatile solute add या solution मध्ये solvent मध्ये केल्यानंतर त्याचं vapor pressure यांच्यामध्ये जो difference जो आहे, that difference is the lowering of that is lowering of vapor pressure. By the vapor pressure of the solution containing non-volatile solute is lower than that of the pure solvent. म्हणजे एखाद्या प्युअर सॉल्व्हंटचं वेपर प्रेशर पेक्षा when the non-volatile solute त्या सॉल्व्हंट मध्ये ऍड केल्यानंतर त्या सोल्युशनचं जे काही वेपर प्रेशर जे आहे हे कमी होतं. And that difference between these two vapor pressures, pure vapor pressure of the pure solvent and vapor pressure of the solution in which the non-volatile solute is added. At that time, the vapor pressure of the pure solvent P1 is greater than the vapor pressure of the solution in which the solute is added. And then the difference between that is the delta or lowering of vapor pressure is P1 minus. Why this is happening? Why the vapor pressure of the solution containing the non-volatile solute is lower than that of the pure solvent? Vapor pressure of the liquid depends on the is with which the molecules escape from the surface of the liquid. When non-volatile solute is dissolved into the solvent, some of the surface molecules of the solvent are replaced by the non-volatile solute molecules, and these solute molecules do not contribute the vapor above the solution. And thus the number of solvent molecules available for the vaporization per unit surface area of the solution is less than the number of the surface of pure solvent. As the result, the solvent molecules at the surface of the solution vaporizes at the lower rate than the pure solvent. Means when the pure solvent is here taken into this container, at that time these vapors will be coming upward, and that creates the pressure on the surface of the solution. But when non-volatile solute is added, non-volatile solute added into the solution, at that time the rate of vaporization of the molecules will be decreased. म्हणजे या ठिकाणी होणारे जे वेपर्स जे आहेत हे फॉर्म होणारे जे वेपर्स हे ज्यावेळेस non-volatile solute हा ऍड केला जातो, at that time the rate of the vaporization will be decreased. Hence the vapor pressure of the solution when the non-volatile solute is added, it is less than the vapor pressure of the pure solvent, and that lower is the vapor pressure of the solution. Lowering of vapor pressure delta P is nothing but it is the या दोन्ही मधला असणारा जो डिफरन्स जो आहे, that difference is called as the lowering of vapor pressure. Then, in case of relative lowering of vapor pressure, the ratio of vapor pressure lowering of solvent divided by the vapor pressure of the pure solvent called lowering of vapor pressure. Thus, lowering of vapor pressure, relative lowering of vapor pressure. What do you mean by the relative lowering of vapor pressure? Relative lowering of vapor pressure is equal. It is nothing but it is the ratio of vapor pressure lowering of solvent divided by the vapor pressure of the pure solvent. Vapor pressure lowering of vapor pressure is equal to delta P minus P1 bar. Delta P by the P1. म्हणजे काय? It is the ratio of lowering of vapor pressure of the solvent divided by vapor pressure of the pure solvent. मग lowering of vapor pressure काय आहे? delta P आणि vapor pressure of the pure solvent that is P1 bar. मग delta P is nothing but delta P is equal to क्या है वो P1 naught minus P1. P1 naught minus P1. Then we will put this value P1 naught minus P1 divided by P1 naught. Relative lowering of vapor pressure is nothing but it is the ratio of vapor pressure, lowering of vapor pressure of the solution divided by the vapor pressure of the pure solvent. And this equation is equal to, this equation shows that delta P by P1 naught is equal to x2 delta P by P1 naught is equal to x2 is equal to P1 naught minus P1 divided by P1 naught. For the rules for the solution of the non-volatile solute, we can say that for the binary solutions containing one solute, x1 is equal to 1 minus x2. If it therefore follows that P1 is equal to P1 naught x1, and instead of x1 value क्या है 1 minus x2 in the rules law, according to the rules law, then that equation becomes finally we will get that the delta P is equal to the x2 P1 naught x2. Therefore, the delta P by P1 naught is equal to x2. x2 is nothing but P1 naught minus P1 divided by P1 naught. The relative lowering of vapor pressure is equal to the mole fraction of the solute in the solution. Therefore, relative low vapor pressure lowering is a qualitative property. म्हणजे या ठिकाणी आपण पाहिलं वेपर प्रेशर लोअरिंग म्हणजे मूलतः लक्षात ठेवणं आपल्याला लक्षात प्युअर सॉल्व्हंटचं वेपर प्रेशर आणि त्यामध्ये when we have added the non-volatile solute into that, at that time the vapor pressure will be decreased because the rate of vapor addition will be decreased due to the non-volatile solute which is added into that pure solvent. At that time, the vapor pressure of the solution decreases, and the difference between the vapor pressure of the pure solvent and the vapor pressure of a solution in which the non-volatile solute is added, and that difference is the relative lowering of vapor pressure. And the relative lowering of vapor pressure म्हणजे काय आहे? It is the ratio of lowering of vapor pressure to the vapor pressure of the pure solvent. Lowering of vapor pressure काय आहे? delta P आहे. Lowering of vapor pressure is nothing but the delta, and pure naught is nothing but it is the vapor pressure of the pure solvent. That is the lowering of relative lowering of vapor pressure. Then the molar mass of solute from the vapor pressure lowering. Molar mass of solute from vapor pressure. Molar mass. From vapor pressure. Lowering. Molar mass. We have studied that the relative lowering of vapor pressure is equal to the mole fraction x2 of the solute in the solution. Therefore, म्हणजे काय आपल्याला माहिती आहे की रिलेटिव्ह लोअरिंग ऑफ वेपर प्रेशर इज नथिंग बट इट इज इक्वल टू द मोल फ्रॅक्शन दॅट इज द x2. x2 इज इक्वल टू काय आहे दॅट इज डेल्टा p बाय p1 नॉट. This is the equation 1. And the mole fraction of the component of the solution is equal to the its mole divided by the total moles in the solution. म्हणजे mole fraction म्हणजे काय आहे x2 is equal to mole fraction is equal to number of moles divided by the total number of moles of the solute. Solve. Hey, equation problem 2. When n1 and n2 are the number of moles of the solvent and the solute, then in the solution we are concerned with only with the dilute solutions. Hence, n1 is greater than the n2, and n1 plus n2 is equal to. When we are concerned only with the dilute solutions आपण concerned करत असताना at that time the n1 is very greater than the n2. Hence, and n1 plus n2 is equal to n1 because we are concerned with the dilute solution. Then the mole fraction x2 can be given by that is x2 is equal to n1 upon instead of n1 plus n2 म्हणजे काय आहे n1 that will be n1. Suppose this is the equation number 3. This is equation number 3. Suppose that we prepare a solution by dissolving the W2 grams of the solute in W1 gram of the solvent. The moles of the solute and the solvent in the solution are that N2 is equal to W2 upon M2. N2 is equal to W2 upon M2 and N1 is equal to W1 upon M1. Therefore, where M1 and M2 are the molar masses of the solvent and the solute, then the substituting the values into the above equation, x2 is equal to delta p by p1 naught is equal to W2 upon M2 divided by W1 upon M1. Then x2 is nothing but P1 naught minus P1 upon P1 naught. P1 naught minus P1 upon P1 naught is equal to delta P upon P1 naught. म्हणजे काय W2 upon M2 divided by W1 upon M1. And knowing all these quantities, the molar mass M2 can be calculated. म्हणजे या सर्व क्वांटिटीज आपल्याला भेटल्यानंतर आपल्याला मोलार मास आपल्याला हे कॅल्क्युलेट करता येतं. Here we'll stop this. Continue the next.